It's a pleasure to have the chance to share our work. My name is James, and I am a founder of TrojAI, and we work to protect AI systems from adversarial attack, data poisoning, model evasion, essentially the hacking of AI. Are there any cyber folks in the audience, cybersecurity? So you might remember in 2015, there was a gentleman that was able to remotely disable a vehicle, a Jeep Cherokee. It's the famous example. I believe his name was Charlie Miller, and he's now a distinguished engineer with Cruise, I believe. So that was sort of a watershed moment with the hacking of vehicles. If you fast forward to 2018, researchers came out with a technique to actually fool the models, the AI model within the vehicle. This is where I started sort of taking notice, and these same researchers 3D printed a turtle, and the turtle had a texture on it such that when a computer vision model would look at the turtle, it would register it as a gun. This will make sense where I'm going in a second. So my background, I'm a computer scientist with an interest in policing. I used to be a crime analyst, and I'm actually still an auxiliary police officer with St. John Police Force. Carrying some COVID weight still. So my view of the world is sort of on the malicious side. Having worked with a police agency as a data scientist, I look for how something is going to harm us. Also have a cybersecurity background. Worked at the Canadian Institute of Cybersecurity, which is located in New Brunswick. We're very proud of that. And I used to be a lead data scientist with Raytheon Canada on the cyber side. Left there and founded a company called EhEye. And at EhEye, we used computer vision to automate the surveillance or monitoring of surveillance video for the early detection of guns and fights. And that company was acquired by Toronto-based Patriot One. They're a publicly traded defense company. And I led their video analytics. And it was during this time that I became concerned of the vulnerabilities around AI. And it really started with that turtle that I saw in 2018. And of course, once an entrepreneur, always an entrepreneur. My co-founder convinced me to leave the stability of a real job and do it all over again. So TrojAI was built or founded in 2019 to build solutions to protect AI systems. And we started actually with computer vision. We operate under the banner of responsible AI. As ML ops folks, I think many of us do. We're all aware of bias and fairness. If your models are making decisions, you need to make sure that those decisions are not treating different groups differently. Interpretability and explainability. If you're taking action on AI models, you need to be able to articulate why you're making the decisions that you're making. The third tenet is robustness and security. So that's where TrojAI plays. So where explainability may help you understand why a model is making the decisions it's making, robustness and security protects the integrity of those decisions. And of course, everything on top of privacy and ethics. There's lots of good work happening on around ethical AI, although I would love to have a longer discussion on ethical AI because I can't help but think, shouldn't everything a company do be done with ethics? I'm not sure why AI is different, but different conversation. And if we do that properly in a responsible manner, then it's up to the public to decide if what we've done is trustworthy. So TrojAI does not build trustworthy AI. We help companies develop responsible AI in such a way that it can be trusted. And the reason we're doing this, not that we want to slow things down or frighten people. We want to protect the pace of innovation that we've come to enjoy. AI is unique, has unique vulnerabilities because the inputs to the AI come from outside of your traditional cybersecurity perimeter. During training, all the different ways that you can curate your data, download open source data sets, scrape the web. Maybe you're outsourcing the annotation of your data. Maybe you've got an insider threat, which is always a cybersecurity issue. One instance that occurred to me personally, we were adding data to our models every month, enough data that we had to outsource the annotation of that work. We actually engaged with a Toronto-based company for that annotation work, and come to find out they were backdooring it to China. So as a defense company, that's a real supply chain issue. The model itself will always contain weaknesses. So we have to recognize that. That's another source of, and I'll talk in a moment why that is. And of course, when you deploy a model, you're taking inputs from the real world. And if you're taking inputs from the real world, there's always opportunity for a malicious actor to inject some sort of noise to game the behavior of your models. So that's the first major challenge of AI, are the unique vulnerabilities of that AI. I'm going to play a video.
Are you worried at all, since you don't have any depth sensors on the car, that people might try like adversarial attacks, like printed out photos or something to try to trick the RGB neural network?
Yeah, like what, pull some like Wile E. Coyote stuff, like paint the tunnel on the wall. It's like, oops. We haven't really seen much of that. I mean, for sure, like right now, most likely, if you had like a t-shirt with like a stop sign on it, which I actually have a t-shirt with a stop sign on it, and then you like flash the car, it will stop. I proved that, but we can obviously, as we see these adversarial attacks, then we can train the cars to notice that, well, it's actually a person wearing a t-shirt with a stop sign on it, so it's probably not a real stop sign.
Okay, so just remember the video. The second biggest reason why TrojAI exists, and this is the challenge of AI in general, are the long-tailed edge cases found in the real world. And in a long tail, over half of the instances that will present to a model actually occur in that long tail. They're unpredictable. They're black swan. Because they're unpredictable, and I say this with all love and respect for data scientists, I'm a data scientist, they cannot be trained in the lab. And the way we train in the lab is with, our state of the art is to look at precision, recall, F1 score, things like that. So the data scientist's job is to build a model that will generalize as wonderfully as it can on the things we know about. But with the long-tailed, over half of the things are occurrences that we don't know about. Any startups, folks here? Watch Silicon Valley? This might call it to Silicon Valley, not a hot dog. You never know what you're going to see driving down the street. A data scientist would never know that they're going to have to include some data on an Oscar Mayer Wiener car going down the street. A couple of other examples. So here's an autonomous vehicle registering traffic signal lights. And he just happens to be driving behind a truck that's carrying the traffic signal lights. Here's another one registering continuous stream of yellow lights. It just happens that on the horizon. I don't know if that's the sun or a moon. But again, another unpredictable edge case that you could never have accounted for because, again, it's unpredictable. It's a black swan event. So I'll come back to the importance of these edge cases in a minute, but I'm going to go through some examples of what edge cases look like. And we look at both naturally occurring edge cases and malicious edge cases. On the naturally occurring, there's actually this paper where they call naturally occurring edge cases adversarial examples. I'm not sure I agree with the terminology, but it actually works quite nicely with how our approach works. So in this case, they've got an overpass on a highway, and the computer vision naturally says, oh, that's a dam. 99% sure that that's a dam. So the long tail is filled with naturally occurring, non-malicious edge cases. So it's not all about, my wife would call me paranoid most days because come from that policing side and see the world in a malicious way. But actually, you have to have both. The robustness and the security go hand in hand. Just as an example of some attacks, this is a resizing attack. And back in 2019, we actually replicated this and poisoned a set of tank images. And we actually hid school bus images inside the tank images. And they're invisible. The data scientists would not see these until they go through the AI pipeline and hit, as natural or standard practice, the AI pipeline will resize your image to a target dimension. There could be several resizing algorithms available. In this case, it's TensorFlow, and there were 4 resizing algorithms. For one of the resizing algorithms, when it hit the target dimension, that tank would actually flip to a school bus. So the result would, if you were doing an automated target recognition system, you would be training that model to treat a tank and a school bus exactly the same way. That was when we started in 2019. We were looking at protecting data poisoning examples. That was our first solution, is to look for that single attack. Embedded Trojan attacks, which is where our name TrojAI came from. So if someone were to get a hold of your data, or you ingested some data, different supply chain issues, and put a geometric shape on your stop sign and flip the annotation from stop sign to speed limit sign, and you only have to modify about 1% to 3% of images, you'd essentially be training an embedded Trojan attack into your model that could be enacted later by simply in the physical world putting a sticky note on a stop sign. The attacks are many. You can get creative. You can ensemble attacks together. So here's an example where the geometric shape is actually hidden through a resizing attack, and then only when it goes through the pipeline does it become visible, and again, leaves you with embedded Trojan attack. There's examples where you don't even need access to the data. In this paper, the authors made graffiti to, or they explored marks until they achieved the behavior they wanted to fool the computer vision. Then they sort of reverse engineered the marks to look like everyday graffiti, so it would be hiding in plain sight. This is one that keeps me up at night. It's an adversarial patch attack. So it's actually possible to reverse engineer a neural net to extract a pattern, and that pattern can be used to cause misclassifications. It can be used to defeat computer vision entirely. And in my case, when we were working with gun detection, the whole use case that company was founded for was the Parliament attack in 2014. Very meaningful work and mission critical. The idea that somebody could take an adversarial patch, maybe put it on their t-shirt, and disappear from the computer vision, that's again sort of what gave rise to the need for TrojAI. So we're actually working with University of British Columbia on the detection of adversarial patches. And in this case, this is an example where an adversarial patch could be used as a sort of digital camouflage. So these are actually photos of Russian planes in the Arctic, and a digital camouflage could be used to hide all sorts of nefarious activities. So we're working on techniques to detect the presence of adversarial patches. The wonderful thing about attacks is I don't really need to know what AI backbone you are using. I can craft an attack on mine, and they typically transfer quite nicely across. Now, if I know what data you might have used in the creation of your model, so for example, June of last year, China open sourced the largest satellite imagery data set that we've ever seen, 1 million scenes annotated for ground truth. So if I were a small company, startup, even a second or third tier provider of computer vision models, you're starved for data. It's very tempting to take data off the shelf and train that into your models. So now, if I'm a nation state, and I don't need to know what AI backbone you're running, but I have a good idea what data you've used, I can craft very effective attacks. Side note, we, about 2 months ago now, published the Secure Model Development Lifecycle framework. And it sort of lays out the entire model development lifecycle with highlighting sort of security, places where security should be considered and where proper tools could be placed to support that. So in something like this, your data science team should be aware of the implications of taking data off the shelf. The number of attacks just keep coming out. So in this case, the researchers were able to craft an attack that the AI model got confused on and treated it as a more complex image than it actually was. And it's basically a denial of service. It spun up the GPUs until they stopped working. So this is the first case that I'm aware of where the actual software vulnerabilities translated into the hardware. And I've got the backdrop of the panda because that's the seminal sort of adversarial attack paper. A lot of people say, well, that's okay, it's just computer vision, my system's multi-sensor. In this work, the authors showed first that the LiDAR point clouds, subset of computer vision, hackable. Putting LiDAR and computer vision together, hackable. So as data scientists or even management in companies, we should all be aware not to dismiss too quickly the possible vulnerabilities. You have to go deeper because even with multi-sensor, you're still at risk. Phantom attacks. Authors started showing signs popping up, maybe in a way that a human would notice on a bulletin board or something. So these are called phantom attacks. And basically, we're seeing a lot of governance organizations come to the realization of the importance of robustness and security, that models are often operating at the boundary of what the capabilities are. And we see robustness and security as two sides of the same coin. That's actually a picture of our Team Challenge coin. The robustness, depending on how you look at it, a duck or a bunny, and security. So, we know there's a problem, and this is not a sales pitch. There are some very good companies operating in the space. What you should be aware of is that you should be looking at some sort of tools to to address these vulnerabilities. So you should have some form of robustness assessment. So this robustness assessment that we're working on is basically a pen test for your model. It will attack your inputs and figure out where the weaknesses are, when it starts to fail, down to the class level. When it does fail, where does it naturally fail towards? We call it failure bias. And basically prioritizing the failures based on the severity, just how bad did we fool it, with how small a perturbation, looking at the distribution out in the real world, how often do we think that's going to occur. And we basically, just like in traditional cybersecurity, we can score and prioritize for data science teams the most impactful vulnerabilities, so that the data science team can be more surgical in their hyper-tuning of their models. We also have a POC, and it's interesting that this is still POC because this was the tool that we started working on first in June of 2019. Scanning a data set and being able to highlight inputs that are out of distribution with the rest of the data. And the way we do this is we basically fingerprint the latent space of the neural net. So when the image goes through and it gets a particular label, we can check that with the fingerprint and see if it matches up or not. Similar mechanism is used in our AI firewall. And this can be used in batch or in real time. And again, it's basically, as the inputs come in through the real world, we need some mechanism to highlight when something is out of distribution. Whether it's naturally occurring or malicious, doesn't matter. If it's out of distribution, we need a way to push control back to the human user, sort of allow the AI to fail more gracefully. This is just a few examples. So here's the adversarial patch attack. I would say camera adds 10 pounds, but I'm standing in front of you and I can't get away with that. So normal operating conditions, you've got your computer vision, adversarial patch comes into view, computer vision ceases to operate. So with the capability of actually detecting the presence of, we can return control back to the driver. The classic data poisoning attack, this is normal stop sign, car comes to a stop. And the embedded Trojan attack. And here's a slight manipulation in the physical world. And fooling the car to interpret that as an 80. Although 30, we're on the east coast of Canada, 30 kilometer an hour, very tricky to find. I had to drive around the entire city to find that 3 to be able to do that. So, back to the original, that original video where someone in the media asked Elon Musk, are you concerned about adversarial attacks? No, not at all. Don't see a lot of them happening. As we see them, we'll simply train them out of the model. I hope through these slides, you see or share in the concern of the long-tail edge cases. That while rare, given a sufficiently large AI system, with the probable and probable, those edge cases will happen every single day. And while some of the examples could be obscure enough to fool a human, Like maybe a human might have looked at that sign and said, oh, that's 80. Most humans won't. And most humans will be able to handle the misinterpretation. With AI, if you fool an AI, you're going to fool all of the AI. And we don't know how it will fail. He also doubled down and said, you don't have to be the world's best driver to be on the road. As someone that unfortunately had to help folks take my mother's driver's license away, she's at that age, I can tell you that that's not a great justification to have an autonomous vehicle that's not vetted for robustness and security. If you're data scientists, I would say you have a strong responsibility to monitor how the statistics are used. There's a misused statement that 94% of crashes are due to human driver error. That stat actually appeared on the National Traffic Safety Board in the US. And all of the autonomous vehicles kind of jumped on it and went, hey, we're going to make our autonomous cars are more safe because in 94% of the time, it's the human that's at fault. Well, if you read deeper, it doesn't say that. It says in 94% of crashes, a human driver may have helped. And in fact, in January, they've removed that from their website. There are still autonomous vehicle makers that are still quoting that on their website. In fact, I contacted one myself last week to alert them that they're still saying this, and it's still there today. The other thing is how they're reporting the fatalities. Like we get far less fatalities with autonomous vehicles. Well, you need some way to normalize that. And the way you normalize it is fatality per mile. And if you do that, we've already used up our budgets for fatalities. So yeah, sometimes it's tough as data scientists to push and be heard, but this stuff's important. So you have to push for robustness and security and make sure your organizations are not misusing statistics. And back in 2019, 2020, 21, I probably needed this slide. I don't think I even need this slide anymore. There's a recognition across enterprises that robustness and security of AI is needed. Even in the last 6 months, we've seen an uptick in just not only acceptance, but what are we going to do about this? It's basically comparable to when the World Wide Web first came out. The innovations that were changing the world daily. AI and the World Wide Web both sit on technology that was built without security in mind. And we've been dealing with that ever since. So the biggest cybersecurity or the most significant cybersecurity issue for the next decade is the robustness and security of AI. Regulation is coming. So companies can either sort of be proactive, take a leadership role, lead by example, or they're going to be forced to. And in the EU, they've already drafted legislation where if you're found to be deploying AI that's not responsible, you can face fines up to 6% of global revenue. So that's likely going to be a large incentive for organizations to get behind this. That's my contact information. Happy to take any questions. If there's any questions I can't answer, I have a smarter guy at the back that I'm going to call on. Yes, Vadim. And Stan's over there too for other technical questions. Yes.
Hi, great talk. So I'm working in this area as well, adversarial machine learning, and there is concerns about, there definitely is a lot of threat. On the protection and defense side, there are concerns around, really good mechanisms for that. What are your thoughts in this area?
Sorry, just so I understand your question. So you're working in the space. You think people are recognizing the need as well. And
Yep.
Sorry, the second part?
Second part is really around defense and protection, right? Like, okay, like these attacks are happening. How do we protect ourselves from this? So, for example, you mentioned like, Elon Musk saying, well, if, this became an issue in the future, we can retrain the models. Like adversarial training is like a, technique to defend against adversarial attacks. It does have a lot of caveats where, you still are like, adversarial accuracy does not go from like, 30% to like 90%. It just goes from like 30 to maybe 50%. And then you're end up making a trade-off with your general accuracy, which goes down when you do that. So yeah, curious about your thoughts, like how, like as this is becoming a bigger problem, do you see issues with lack of techniques on defense, or do you think it's just something that is a solved problem?
We're far from a solved problem, and there's going to be no silver bullet just with the architectures of AI that we're using. I would say we need more techniques. We're a startup. We have to go through that sort of business development. We track startups in the space. There's an influx of new companies coming in, which is fantastic. But it's such a technical area as well. So it's not just building, like being technical enough to build models. It's being technical enough to know how to protect them. And there's limitations absolutely everywhere. And it's going to take a multi-tooled approach. So we recommend looking at making sure your training data is protected, and that the model is also assessed so you know where the vulnerabilities are, and then some sort of firewall to protect the inputs. You're right, there's other techniques that you could apply, like adversarial learning. Of course, we've seen examples where you do adversarial learning and your general accuracy dumps from 90 down to 25% or something. That's a whole other area of research. We have seen examples where we've been able to improve the robustness and the accuracy using other techniques like smoothing of models. Stan, is there anything else that I can share? You were zoned out. Nope.
Oh, well, I'll just say, in the space of computer vision, which was what this talk was primarily about, the computer vision space, as we all know, is incredibly massive. The search space is incredibly massive. And measuring drift of computer vision models to determine some sort of likelihood of one of these attacks being enacted in the real world is extremely hard. So you want to be able to expand your distribution in kind of a controlled way, and that's what we do. If we solved every single edge case in the computer vision space or any space, you're essentially saying, well, can we solve model generalizability, which is obviously not the case. So there are particular subsets of drift, and measuring the impact of those drift and synthetic data points in the real world, which is kind of an incremental, shippable intermediate that we're trying to achieve. So hopefully that answers your question.
And to our competitors in the room, he's ours.
So to comment to something that came up earlier, is model complexity like inherently good or bad from a security perspective? Because I've heard it said that a lot of the AI problems are kind of solved with greater complexity. I'm not sure if I believe it, but there's kind of a little bit of that going on. Is that true of the security world, or does higher complexity just mean a longer tail?
I hate saying it's a good question, because who am I to judge a good question? But I would say, and I would defer normally to our principal data scientists, I don't think the answer is just throwing more complexity and more data at it. In fact, I think the way we're solving AI today is limited. And we're dealing with that every day. So we have what we have, unfortunately, and we need to come up with clever ways to mitigate the risk. But in my opinion, a more complex model is not necessarily the way to go, because you're still going to have, no matter what you train, over half of the instances are still going to be unpredictable. So they're still going to be outside of that expected population of things that you're trying to train and generalize to. Yeah, but I can stand to be corrected.
Thank you.
Thank you.
Yeah, hello. I may just second to that. I would like to hear your opinion on the explainable machine learning. We may not call it even a machine learning. I mean, like feature extraction and other processing methods, instead of like throwing deep neural networks at everything, every problem that we see. So maybe what is your stance on top of that? Well, if you are what is your stance on that?
So I'm going to go back to my responsible AI slide. And if there's any new startups that are, looking to get into the space, inevitably, when they make their first website, they say, we do this, 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 and this. You can't. Each one of these pillars are separate disciplines unto themselves, takes separate expertise. Of course, there's some overlap. Like there's an element of explainability with what we do because we're surfacing vulnerabilities. But I would never claim to know enough about explainability to even know where the limitations are. I would also not, and I've seen examples where companies will potentially dismiss a pillar because it is limited in what it can do. So we know the explainability space is limited. Robustness and security space is limited. But you can't kind of kick over a pillar and say, well, if you just focus on this, you don't have to worry about that. So that's a long-winded question to talk all around your question, that I'm not really an explainability guy.
Okay.
And I would say similarly, adding more complexity, more data, well, I guess for explainability, it might even, just anecdotally, it would probably make it less explainable.
Yeah, it usually does.
Yeah. So
basically what you mean is that if we really want to have a responsible AI, we should actually do all of the three.
You absolutely have to have elements of all three, which is really tough right now because no one company, it's just the nature of our maturity as, as an MLOps community, it doesn't exist yet. So somewhere along the line, there's likely going to be consolidation, and certain companies will get paired off with other ones. But then add on the different disciplines of AI. So, one company could be best of breed in computer vision, security, or explainability. But what about natural language processing? What about structured tabular? What about audio? Yeah. So we're in the infancy, I think, and we need somehow to catch up with some sort of solution to protect the public. Yeah.
Thanks.
Thank you.
These types of attacks which are happening, they can be white box attacks or black box attacks. Usually it is the case that, the open source community, when they launch a new model or something, the weights and everything are available just online. And smaller startups or smaller companies, when they are exploring a new experiment or something, they just use the same models, and those are easier to break. But how do you feel that, having more custom models, having more custom training, that, I can take an open source model, and then if I can do something on robustness, on training, and then make a custom model for my particular use case, would that help, and can that be generalized in different domains? That is.
So I've read about examples where, let's say you've got a model that contains an embedded attack that attack will persist even if you transfer learn.
Yeah.
Now, no matter, even if you didn't use a third-party model, if you just baked your own, which is, I mean, as a startup, that's a tough order to,
Yeah.
you know. But even then, you still have a robustness issue, and you still have security issue. And it all goes back to that long tail, because when you train the model, you just don't know what's going to be in that long tail. So yeah, I don't think it matters if you take it off the shelf, if you transfer learn it, or you bake your own. You're still get a robustness and security issue, or that needs to be addressed.
Yeah, the main point is that means for those larger models, a startup cannot even do a robust training.
Yeah,
No.
like how are you going to do a GPT or something?
Yeah, so means if I'm just trying to means if I'm just talking about the training sense, if I'm just training it normally, if I want to do one iteration, if I'm doing instead a robust training, I have to do 4 or 5 iterations of the same image just to make those boundaries smoother and make
I don't even want to say it should help. It could potentially help, depending on how long you transfer learn and to your own specific use cases. But under the banner of responsible AI, you should have a way to, like, data scientists often get challenged on, you know, prove that what you're building is robust, and they think in terms of their accuracy metrics. And of course, we're all biased because we're like, well, I build for generalizability. Yeah, but what are you doing? How do you demonstrate to stakeholders what your robustness is to the unpredictable edge cases around it?
Yeah.
So no matter what you do, you should have a way to assess what you're doing for that robustness. And I've seen cases where accuracy metrics actually went to the board for their models. Well, you can game your accuracy metrics and actually make a worse model, more brittle model. So, yeah.
That makes sense. Thanks so much.
Thank you.